Great. Well, great to be here. So today I'm going to talk about app configuration. Now, if you've heard of feature flags, you can think of them as the tip of the app configuration shaped iceberg. Now, the best way to understand what app configuration is to see it in action. So let's imagine we're a SaaS company called Potion, and this is this is our mobile app, and it's the plans page of our mobile app where users can subscribe to one of our paid plans. Now, let's say the marketing team wants to run a 20% discount across all of the paid plans. So they ask us, the engineering team, for help. So what we'll do is go into our code base and we'll write some code to implement this 20% discount for them. So we'll do that. And once we're happy with how that looks, we'll deploy it to a test or staging environment. And we'll send the marketing team a link so they can test it out and make sure that this discount looks good. So they do that and they tell us that the discount looks good. We're ready for it to go to production. So we submit this code to production now. And then once it's live, we tell the marketing team, and then they confirm that it looks good again. And the discount is running in production. But then after a few days, the marketing team says that they want to pause the discount. So we have to go back into the code base and make the change to disable the discount. And then we have to deploy this to production, which takes some time. And then we'll tell the marketing team it's paused. They confirm that it's paused. And then we don't hear from them for a while. But then after a few days, they get back to us and they say they're ready to resume the discount. Now, this is getting a bit tedious for us. So we decide to put the discount behind a feature flag that the marketing team can toggle on and off themselves. Now, we've already set up a feature flag system in our app called Hypertune. So what we'll do is go into the UI for Hypertune, and we'll create a new feature flag, and we'll call it is discount enabled. And this will be a boolean, which just means it could be either on or off. And we'll leave it off for now, and we'll save that. Then we'll go into our code base and we'll run npx hypertune to regenerate our type-safe client. And we'll use the feature flag in our code. So we'll write hypertune dot is discount enabled, and we'll pass a fallback value of false. And then we'll deploy this to production. And then we'll tell the marketing team they can now control whether the discount is enabled from this flag in the UI. So right now it's off, but they can flip it on and then hit save, and then the discount appears. So this is great, as now they can make changes to the discount themselves without having to ask us every time. And then we don't have to wait for them to tell us when the discount should be live. So our work streams are decoupled and we can both move a lot faster. And because it's a flag, they can also add more complex logic now to say who the discount should be on for. So they actually decide that they only want to run the discount in the UK. So they can add a rule to say if the user's country is one of this list of countries and they add the UK here, then the discount is on. Otherwise, for users in all the other countries, it's off. And whenever they make a change here, it's updated instantly. So they don't have to wait for a code deployment or an app release. They can see their changes live immediately. And the other great thing about having this flag is they can also run an A/B test on the discount. So rather than it just be on for everyone, they can drop in an A/B test here, and they can set it on for half of users, off for the other half. And then this would let them measure the impact of running the discount on the metrics they care about, like signups, revenue, profit, and so on. So we don't hear from the marketing team for a while because this system is working pretty well. They're not bothering us to change the discount logic. But then one day we hear from them and they tell us that instead of running a 20% discount here, they want to run a 40% discount. Now, the problem is that this 20% was hard coded in the code base. So we need to change it for them to 40%. But we could just change it for them, but then that would lead to that same slow back and forth process that we had before we had the feature flag. So let's see if there's something that we can do to give them control over this percentage as well. So one thing that we can do is in the Hypertune UI, instead of returning a true or false boolean from this flag, we could return a whole discount object with subfields to say whether the discount should be on, and another field to say what the percentage should be. So to do that, we'll go into the schema in Hypertune, and we'll define a new object type called discount. So we've actually set one up here already, and we've got a field, this Boolean field called is enabled, and another field called percentage, which is a float. And we'll remove this field for now. So we'll deprecate this Boolean flag, and we'll add a new flag called discount. And instead of returning a Boolean, we'll return a discount object type. We'll save that, and then we'll go back into the code base and run npx hypertune to regenerate our client. And then we'll see a type error where we're still using that deprecated flag. So we'll replace that with the new flag, which is hypertune.discount.isEnabled. And we'll also replace this hard-coded percentage with hypertune.discount.percentage, and we'll pass a fallback value of 0 here. So we'll deploy this to production, and then we'll tell the marketing team that they can now control whether the discount is on or off, just like before, but now they can also control the percentage. So instead of 20%, they can have 40% here. But just like before, they can also have complex logic to say who the discount should be enabled for, so they can have it on for specific countries. And they can have that same kind of logic for the percentage, so they can have different percentages for different users, or even A/B test the percentage to see which percentage works best. So they're pretty happy with this system. They're pretty excited, and in their excitement, they ask whether they can also control the copy, which we show next to the discount over here as well. So instead of summer sale, they can have different messaging and see which one works best. So to do that, we'll go back into the schema for our discount object type, and we'll add a new field called name, which we'll set to a string. And here's where we'll control the copy that we show to the user. So we'll save that, and then we'll go into our code base and run npx hypertune. And then we'll replace this hard-coded copy with hypertune.discount.name, and we'll pass a fallback value of just discount. So we'll deploy this to production, and now the marketing team can control the copy of the discount too. So by default, it's summer sale. But like we said, they want to test different variations of this messaging to see which one works best. So instead of summer sale, they decide to drop in an ABC test to test a few different variations of this copy. So they have summer sale ends soon, and summer sale ends today. And now, instead of running a traditional experiment where they wait for the experiment to run and then see which variation works best and then ship that variation to 100%, they instead go to the experiment page in Hypertune and they set it to a machine learning loop so that Hypertune will automatically converge on the best variant over time to maximize the number of upgrades. And it can also take into account user attributes to learn if the best variant is different for different types of users. So They're pretty happy with this system now. They can control the copy, automatically personalize it to each user with machine learning, control the percentage and whether the discount is enabled. So we don't hear from them for a long while. They're happy using the system. But then one day we hear from them and they come to us with a complex use case. They want to run a 20% discount for all of their users, but they want an additional 10% discount for users who enter a special discount code. So they need a way to run multiple overlapping discounts at the same time. So now, instead of a flag which returns just one discount object, we actually want a flag which returns a list of discount objects. So we'll deprecate this discount flag and we'll create a new flag called discounts, which returns a list of discounts. And we'll save that and then go back into our code base. Uh, before we regenerate the client, we'll actually go into the schema and we'll actually switch into GraphQL mode and we'll see that new discounts flag that we created. And we'll actually add an argument to this flag called code, which will be a string. And this will be the discount code which the user enters, and we'll be able to use that in our logic for the discounts flag. So we'll save that. Then we'll regenerate our client. And then we'll see a type error where we're still using this old discount flag. And instead, we will use this new hypertune.discounts flag. And we'll pass in the code that the user enters as an argument, and then we'll map over each discount, converting it into a plain JavaScript object. And then we'll filter them by the discounts which are enabled. So we'll deploy all this to production, and then we'll tell the marketing team they can now add as many discounts as they like to this list flag. So the first thing they do is they add a discount called summer sale, which is on for everyone, and it is for 20%. And so they save that, and they can see that live in the app immediately. And then they add a second discount, but this time it's only enabled if the user has entered a special code, which is React and chill. And otherwise it's off. And this is for an additional 10%. And this will be the React and chill discount. So they save that. And now we don't see the discount yet, but if the user enters that code, then we'll see that extra 10% discount appear. Cool. So just like before, they can have complex logic for each discount to say whether it should be on or off, or to A/B test it. They can have logic to have different percentages depending on which users are looking at the discount. And they can use machine learning to personalize the copy to each user to maximize the number of upgrades. So with minimal engineering work, we've converted this simple Boolean feature flag that we had before into this flag which returns a list of discount objects. And we've empowered our marketing team with this flexible platform to manage discounts themselves. Now, we actually had an app configuration system just like this, or similar to this, at Meta, and it was called Configurator. And it was used in a similar way to platformize products and backend services at Facebook. And Meta actually released a paper on this called Holistic Configuration Management at Facebook. And it dives into how Configurator was used for lots of different use cases. For example, it was used to configure automated backend jobs, like user notifications, where you can configure templates for different notification types. pricing, billing, and discounts, like we've just shown in the demo, permissions and features available to users, API rate limits, in-app copy for guidance, error messages, tooltips, modals, forms and wizards, metrics, health checks, and alerts, search and ranking configuration, rules, policies, filters, and classification thresholds, machine learning model parameters and versioning, complex rollouts, kill switches, and experiments, constant API keys and third-party integration settings, and this large long tail of niche configuration use cases. But across all of these different use cases, we got the same high-level benefits. Number one, we decoupled dependencies in our organization so we could enable other teams to self-serve and make changes themselves without the slow back and forth process with engineering. And as engineers, we could focus on shipping code to production without being blocked by other stakeholders. Number two, we got instant updates decoupled from code deployments and the release cycle. Number three, once we had all of this configuration, we could optimize it with hand tuning, A/B testing, and machine learning. Number four, we reduced complexity by extracting all this configuration logic, like user-specific code, out of different code bases and into a single source of truth. And we also got this clean separation of concerns between code and configuration. So we could focus on the high-level logic in our code and worry about the configuration details later or delegate that to another stakeholder. And number five, we got increased flexibility. So after writing our code, we could configure it in lots of different ways without any extra engineering work. So app configuration is great, but how do we go about building a general app configuration system that can scale to complex use cases? The first thing we need is a flexible type system to define the inputs going into our system, like the current environment or user, and the outputs coming out of our system, like the feature flags or the list of discounts or the list of onboarding guides in our app. The second thing we need is a flexible configuration language to define the logic that maps those inputs to the outputs. So we should be able we should be able to embed A/B tests and machine learning loops into our logic too. And we need a UI for non-technical people to edit the logic visually. So when we combine those two ingredients, the flexible type system and a flexible visual configuration language, we can scale to all of those complex use cases that we went through earlier. So this is really powerful, but it's also a bit scary because we're moving critical business logic out of our code base and into this configuration system. So if the system fails or we make an incorrect change, it could cause major issues like the one CrowdStrike experienced recently. And we also don't want to impact the performance or efficiency of our app by depending on a configuration system. So how can we make the configuration system as safe, reliable, performant, and efficient as our own code? First, we can design the SDK to locally evaluate our configuration logic. So it fetches all the configuration logic from the server upfront in one initial network request. And then after that, there's no dependency on the network to evaluate configuration. So it's super reliable, performant, and efficient. But we still have that one initial request which could fail. So to make this more robust, we can include a snapshot of our configuration logic in our app bundle. So the SDK can use that as a fallback in case it can't initialize from the server. And we can also set up a webhook to trigger a new build and deploy of our app whenever the configuration logic changes, so we can keep that build time snapshot up to date. And then if we do that, if we have that build time snapshot, then we don't even need to initialize from the server at all. And we can use the SDK in local only offline mode. But then we do lose the benefit of being able to update the configuration instantly. But with a blended approach where we initialize from the server and we have the build time snapshot, we get the best of both worlds. The next thing we can do is that when we evaluate configuration, we can also pass hard-coded fallback values for the case when the SDK hasn't initialized and when there's no build time snapshot. And we can also ensure that the configuration is evaluated with full end-to-end type safety to avoid typos, catch errors at compile time rather than runtime, and enable this great developer experience with IDE features like code completion, find all references, and JS comments. And then finally, we can version control all of our configuration logic in a Git style history. So we can see exactly what changed and when, with clean diffs of our logic and schema changes, and branches, the test and preview configuration changes before merging them into the main branch with a pull request. So we manage our configuration just like we manage our code base. And we can also layer on team roles and permissions to safely onboard non-technical team members by requiring that all their changes are first reviewed in a pull request. So to recap, with this local evaluation, build time snapshots, type safety, and Git style version control, we can get a similar level of safety, reliability, performance, and efficiency as our own code. There was no tool out there like this, so we built Hypertune, and here are some links to check us out. It's free to get started, and the setup takes under 10 minutes. So why did we decide to work on this? Well, we believe there's a lot of slow back and forth that happens in organizations during software development. There's a lot of waiting for updates to reach production, especially for apps with a slow release cycle, like mobile apps. There's a lot of low-hanging fruit to improve product conversion rates and the overall efficiency of software systems, especially as they scale. There's a lot of complexity in those software systems that can be simplified, and there's a lot of slow iteration. And we believe that app configuration, when done in the right way, can be the solution to those problems. So thanks for listening. I hope you enjoyed the talk.